Spring Framework Overview and Tools. So these are the set of topics we are going to cover in this presentation. So we'll talk about what Spring Framework is all about and why you want to use a Spring Framework for building your application. We will look into Spring Framework architecture from 3,000 feet or 30,000 feet standpoint, and we'll talk about some usage scenarios of Spring Framework, and then we are going to talk about the tools we are going to use in this course. Basically, the tool we are going to use in this course is a Spring Tool Suite, STS in short. What is Spring Framework? You can think of Spring Framework as a lightweight yet comprehensive framework for building many different types of Java applications. Of course, the most popular type of application you're going to build with the Spring Framework is web application using Spring MVC framework, and enterprise applications as well. So by enterprise applications, we are talking about including EJB kind of things or Java EE related technologies. You can certainly create a standalone applications using Spring Framework. You can build a batch application, you can build integration application, you can even build mobile applications. The things you can build with Spring Framework. So if you're using Spring Tool Suite, when you are creating Spring application, it in fact presents you with a set of applications you can build. These are basically the templates that you can create. So if you select some of these options, it will create template Spring applications based on your selections here, including creation of the pom.xml file for Maven project. You can certainly create a Gradle as an option for build tool. Then it will create a Gradle build file, and then it will actually have created a bunch of template directories and the configurations and the sample files. So as you can see, you can build all kinds of applications using Spring Framework. Let's talk about the key features of Spring Framework, starting with dependency injection. So understanding of dependency injection is very important. Dependency injection is used in pretty much all frameworks these days. So this is not just a Spring Framework, even though I believe Spring Framework is the one that actually popularized the usage of the Spring dependency injection inside a framework. So basically, by having dependency injection as a key feature, bean wiring is done through this dependency injection. So basically, it eliminates a manual wiring of beans. And we're going to talk about dependency injection in detail moving forward in our next presentation. So if you don't understand what I'm talking about on this slide, don't worry about it too much. Or core bean factory, which is usable globally. So basically, bean factory, you can think of it as the representation of all the beans that have been created and wired, and you can access this bean factory object, and then from the bean factory object you can access all the beans. So Spring MVC uses this bean factory object internally. Persistence is also a very important feature of Spring Framework. So it does support comprehensive relational database support, and recently they added the support for NoSQL, such as MongoDB. So we are going to cover this persistence features of Spring Framework in detail on day 4. Basically, Spring persistence layer provides a generic abstraction for database transaction management. It does support JDBC, but it does also support OL mapper technology such as Hibernate and JPA. And even for JDBC, which is pretty lower layer than OL mapper layer, it actually provides higher level abstraction. So if you have to use JDBC, you can actually use this higher abstraction layer, which is a lot more convenient than raw JDBC APIs. And we're going to cover all these things later on. Web tier. Spring MVC Web Application Framework provides the features pretty much all the features that you need to build highly scalable, highly performing, and highly maintainable web applications, and it's built on the top of core Spring functionality, which includes dependency injection. It does support many technologies for generating views, including time leaf. So time leaf is becoming very popular template technology, replacing JSP. But there are a few other template technologies such as velocity, free marker, and things like that. And these are all supported in Spring MVC framework. In this code camp, we are going to mostly focus on JSP, mainly because JSP is still the most popular template technology, even though technologically it's not as exciting as time leaf and velocity and free marker. Spring Webflow is also included. By using Spring Webflow, you can externalize navigation logic. So you can basically capture your navigation logic either in a form of XML file or Java configuration file, and you can apply the navigation logic in many different applications. So basically, navigation logic is externalized, thus reusable. REST support is built in, so it's very simple to build and deploy RESTful services in Spring MVC framework. Default over configuration. So this design principle is again is everywhere in modern frameworks. So Spring MVC is not an exception, taking advantage of this default over configuration design principle. So basically, you as a developer don't have to specify that much, because 80% of the time, you want to use the defaults, and those defaults are automatically used. So the only time that you have to specify particular configuration is when you are deviating from those defaults. But in Spring MVC, everything is configurable and everything is customizable as well. Spring supports AOP, aspect-oriented programming. So, for support for transaction management or security, they are using AOP underneath. And you can certainly provide your own AOP, the featured functionality in your applications as well. We're going to cover Spring AOP in a bit more detail later on in this code camp. So just like dependency injection, AOP improves modularity of the systems built on the top of Spring framework. Test is very important, so Spring strongly encourages building testing logic, testing code along with your application. So it does support unit testing and integration testing of Spring components. We are going to cover both unit testing and integration testing later on in this code camp. So integration testing is very exciting in the sense that you don't have to have a container up and running, but you can still actually cover the multiple layers of the functionality, especially for web applications. In terms of unit testing, it does support both JUnit and TestNG. And another key feature of the testing feature in Spring Framework is that it provides a consistent loading of Spring context object and caching of those context object. So as we are going to learn in the next presentation, application context is basically representation of the DI container, dependency injection container. So you can actually access all the beans that have been instantiated and wired together. It provides a Maga object so that you can use the Maga object in your the unit testing. So we're going to actually learn Mockito as the mocking scheme in our unit testing unit testing presentation and hands-on lab. Okay, so those are key features of Spring Framework. Now let's talk about why you want to use a Spring Framework. Again, the features that are provided by the Spring Framework are the main reasons why you want to use a Spring Framework. Again, you can perform wiring or configuring of components through dependency injection. So by using dependency injection, your components can be decoupled. So that promotes decoupling among parts that make up an application. Designed to Java interfaces. So in Spring Framework, everything is in the form of interfaces and their implementation. So it basically has a set of interfaces, and then it comes with the built-in implementations of those interfaces. So for customization, the only thing you have to do is basically to build your own implementation according to the interfaces. So we're going to actually talk about these things in a bit more detail later on. Test-driven development, TDD in short. So in Spring Framework, everything is in the form of POJO classes, meaning POJO classes basically just captures the business logic, and whatever dependencies are being injected through dependency injection. So POJO classes, which represent your business logics, can be tested without being tied up with the framework. So this is important in a sense that today you're using Spring Framework for building your application. Later on in the future, you might want to actually migrate to different framework, and it's very important to have your business logic in the form of POJOs so that migration to a different framework in the future could be possible. Okay, why use a Spring Framework? Continuation from the previous slide. So declarative programming through AOP. So as I said before, Spring Framework take advantage of AOP, aspect-oriented programming feature, to build some of the features that are important, such as transaction and security. Those are built in into the framework and is built on the top of AOP features. And you can certainly actually build your own functionality in the form of AOP, such as logging. Simplify use of popular technologies. So basically, as I said before, Spring Framework is a set of interfaces and then built-in implementations of those interfaces. So basically, the features are abstracted in a form of interfaces. And so from the user of those functionality, they are insulated from the implementation detail of those functionalities. Underlying technology specifics still accessible. So if you want to, typically you can actually, typically you're going to work with interfaces, but if you have to actually have technology specific implementation access, then those are still possible. It handles common error conditions. Error handling is actually very important in any application, and Spring Framework provides the error handling layers that are common for all applications, and that actually lets you have a portability of the applications. Conversion of checked exceptions to unchecked exceptions. So this is one of the things that Spring Framework does. So in Java community, checked versus unchecked exception handling has been the topic of the debate. Spring Framework has the opinion of every exception should be the unchecked exception so that your code could be simpler. It's not all or nothing solution. What that means is that Spring Framework is constructed in a modular plugin architecture in a sense. So basically, if you don't like a particular functionality of the Spring Framework, you can just plug in your own implementation of it. Okay, so it's extremely modular and extremely flexible. And it is very well designed, and I think that's the reason why Spring Framework is still the most popular the framework for building web applications and even for building enterprise applications. The well-designed feature include easy to extend and many usable classes. So in most cases, the classes that built-in implementation classes that come with Spring Framework should be adequate, but if you don't like, again, particular implementation, you can extend it or you can replace it with your own implementation. Integration with other technologies. All kinds of technologies can be pluggable and were built in Spring Framework. JPA, Hibernate, and JDBC, those are provided for data access. For presentation, meaning template technology, timely velocity, free marker, and JSP, those are all provided as part of the framework. For web, JSF, if you like to use the JSF as a component-based the web framework, then you can certainly plug in JSF into Spring framework as well. We get struts, so again, Spring does not preclude the usage of other technologies. And these days, front-end UIs are typically built using front-end JavaScript frameworks such as AngularJS and the AngularJS Backbone JS and things like that. And those are certainly pluggable into Spring framework as well. For messaging, ActiveMQ and AMQP, so a bunch of other messaging servers could be plugged into Spring framework. And in our Spring JMS presentation hands-on lab, we are going to in fact use ActiveMQ as the open source and free messaging server for our hands-on lab. Okay, so moving forward, any questions so far? Okay, so let's talk about the Spring Framework architecture a bit. So this is Spring Framework architecture. So on the bottom, testing is important. And then inside the core container, you have the beans, core features, context, and SPEL. So these are provided by Spring Core Container. And then AOP and aspects, instrumentation, and messaging. So those are the features that are built on the top of core container. And for web applications, it does support WebSocket now. So WebSocket is introduced in HTML5 and is actually very useful technologies for pushing some data from the server to the clients. Servlet has been supported for a long time. Servlet and Portlet and web. So those are the important features of the web technologies. Data access and integration, so you're talking about JDBC support, OL mapper such as the JPA and Hibernate, and OXM messaging, and the marshalling, so JSON, XML, and things like that. And JMS is for messaging APIs, and also it does support the transaction. So these are some of the key features that come with the framework. Usage scenarios. So basically you can build any kind of application using Spring Framework. So on the bottom, Spring Framework is a dependency injection container, so you can build any kind of applications on the top of it. And one primary example of those, the high-level application framework is Spring MVC. But basically you can build any kinds of applications, including mobile applications. Okay, so this is the Spring Web application. So on the bottom, typically they will use OL mapper, and then it will use the transaction. Typically, you're going to use the annotation-based transaction features that come with a Spring Framework, and then you are going to define domains, and then on the right side, you can certainly perform some remote access. So here you can perform RESTful access or the SOAP-based access and things like that. And then web application context. So basically, web application context is the context object that captures web layer, the beans. And on the top, these are the common features typical web application should have: a form handling and controllers, multi-part resolver for uploading files to the server, dynamic binding to domain model. So basically the binding of the data that is coming from the client to the domain object or command object. And then on the right side, integration with the JSP, Velocity, SLT, PDF, Excel. So basically it does support a bunch of different view technologies. Again, we're going to talk about all these things in detail in our Spring MVC presentations. Okay, so we covered Spring MVC features and architecture and motivation for building a Spring MVC, motivation for using Spring framework. Now let's talk about the tools we are going to use in this code camp. So Spring Source Tool Suite, STS in short. So this is based on Eclipse. So Eclipse powered development environment for building Spring powered enterprise applications. So it does support Java, Spring, Groovy, and Grails. And it comes with the a server, so you can deploy your application on this server. These servers are the enhanced version of the Tomcat. In our code camp, we are going to use built-in the embedded server. So the using built-in embedded server is a lot faster in terms of development time. We don't have to actually deploy and then start the application. However, you can certainly, once you actually have done the testing and the debugging and all those things, they can certainly create a WAR file and you can deploy on any server of your choice. Okay, so we are going to do our first lab. So here we're gonna do just exercise 1, download and install STS. I assume many of you have done already installation of STS, but for those of you who haven't, let me just describe the process. So in order to get the hands-on lab, basically go to jpassion.com and log in with your paying membership, and then go to, let's actually go to the courses, and then click Spring Framework Programming, and then you're going to click lab. For those of you who are taking Spring Framework course in parlays.com, the lab files are posted along with each of those topics. Okay, but if you're taking courses from jpassion.com, you go to Spring Framework course webpage, and then you're going to download the lab file and you save it somewhere, then you unzip it. Okay, so once you unzip it, so let me actually, I have that file, so I already have STS zip file. So you are going to unzip it. You can unzip using any utility of your choice. Okay, in this case I'm going to use the jar xvf command. Okay, by the way, I assumed you have installed Java 8 JDK 1.8 already in your platform. Okay, and then you are going to, so it actually creates a Spring STS directory. Underneath there is index.html file, and that is the lab documentation. Okay, so let me just read that index. So I'm going to actually go to the labs directory, which I have unzipped the Spring STS zip file. So this is basically for people who are taking jpassion.com code camp for the first time. I'm just giving you instruction how to take jpassion.com code camp. Basically, when you do the lab, you just download the zip file, unzip it, then read the index.html file, which is a lab documentation. So we're going to do just exercise 1. So here we are going to download and install Spring STS. Okay, so you go to download STS website, you go here, and then basically you are going to download it. Okay, yeah, so Spring STS